We're going to hear from Christina Batamanu about proxying botnets. And yeah, if you're all settled down, we can start.
Thank you. Hi, I'm Christina. And today I would like to talk to you about the work of an entire team researching a network of proxy computers designed to hide very well different command and control servers. So first I will give some general information, then I will talk about the architecture of the network. I will talk about abuse reports and their solutions, and after a few statistics we will conclude. So I think everyone in the room knows what botnets are and how they work. So a botnet is a number of infected computers that are trying to connect to one or more servers. And once the connection is established, the server sends different commands to the zombies, to the infected computers. These computers will execute them, and they will cause damages through different payloads. So the typical answers from the antivirus solutions are blacklisting IPs or domain names, and eventually takedowns. So the main component here is the connection. And the interest is to keep the servers up and running for as long as possible. And in order to do that, it is needed to anonymize the so-called connection. Through time, the malware creators tried different techniques like DGAs, domain generating algorithms, but it was not enough. Malware researcher can extract the algorithm and can generate the domain names, sinkhole them, blacklist them, and eventually they can take down the botnet. So there is a strong demand for a solution, and therefore it was inevitable not to see an offer of specialized solution, specialized system that can offer a good anonymization of the connection between a server and their infected computers. And this can be seen as a business model. So we have the malware creator, and he buys this specialized service. He offers the command and control server, and he infects as many users as possible. And this is all he has to do. These guys right here, handling the specialized service, will ensure that the connection with the command and control server will be hidden from all the curious eyes. So the infected computer will communicate only with this service, this system, and the administrator, let's say, will send the request to the CNC and will send back the command to the infected user. We actually stumbled on one of these networks during our investigation with CryptoLocker. This network has, as far as we know, 2 levels of proxies protecting the command and control servers, and a central DNS server that handles the traffic. The architecture of the network is very complex and very flexible to the changes. They can do, and they do, a lot of changes almost every day. And this network serves different kind of families, malware families, as Citadel, CryptoLocker, Smoke Loader, and also fake IVs, frauds, and scams. At the moment, this network has 10 clients. When we discovered it, it had only 9 clients. 8 were active, 1 was inactive. And as I said, it has, as far as we know, 2 levels of proxies. For each client, at the first level of proxy, it exists a set of dedicated machines, from 1 machine to 6, 7. And on the second level of proxy, each client has just one dedicated machine. The machines from the first level of proxy communicate with both the central DNS server and with the machine corresponding in the second level of proxy. So going into details for the first level of proxy, we discovered that these machines are responsible for traffic redirection, the UDP traffic on port 53, and the HTTP traffic on port 80. The first level machines are actually set as authorities name servers for a set of domain names specific for a malware handled by the network. So any DNS resolution arrives here. All the traffic received on port 53 is redirected through a specialized service to the central DNS server. The server chooses randomly 4 IPs from the list of IPs assigned to the current client and gives this answer back to the machine from the first level. The machine gives it back to the infected user, and the infected computer chooses one of these IP and sends to it a HTTP request on port 80. All the traffic received on port 80 will be redirected through the same service to the corresponding machine from the second level of proxy. So here we have an example. We have a user that was infected with malware X. The malware tries to connect to a domain name, let's say DX, and sends a UDP request on port 53 on one of the machines from the first level. In the example, we choose the machines for the client 4. This machine will forward the request on port 1000+4 to the central DNS server. The port used in this way benefits the server to identify which client sent which traffic corresponds to which client. So when it arrives, it chooses 4 IPs from the list of IPs assigned to client 4 and sends the answer back to the user. The user chooses 1 IP, let's say it is IP4N, and sends an HTTP request. As I said, all the traffic received on port 80 will be redirected to the machine corresponding on the second level of proxy. Okay, so all the machines from the first level have a major component. It is an encrypted binary file named map. It has 2 main functionalities. First one is self-update. It checks from time to time for new versions. And the second one is the update for the file service XML. This is the file that describes the service responsible for the traffic redirection. And the structure can be seen in the picture from the current slide. The central DNS server, it has 3 main activities. As I've said, it resolves the DNS queries. It serves update for the service XML file, and it represents the management interface for all the 10 clients. During our investigation, this server was moved from one machine to another, and with the help of local authorities, we were able to analyze a collection of PHP scripts. that can be divided in 3 main categories: admin, checker, and system. The admin component can be described by 3 of these scripts, handling information about the servers, the clients, and the domain names. The first one is index.php. It is able to delete a server from the SQL database. The information about the servers is held in an SQL database in a table named, of course, servers. And it has the capability to delete a server or to modify information about the existing servers. If no parameters is given to the script, it displays information on the web interface, information as the country where the server is located, the IP, usernames, passwords, and so on. The second script, user.php, handles information about the clients. Every information about the clients is held in a specific file on the central DNS server. Each client has one file. The name of the file is given by the client ID. This script is able to add a new file and to save this information, to add a new client and to save the information in the file. And it is able to edit information about the existing clients. Of course, without parameters, it will display information in the web interface. The last one, domains.php, will handle the information about the domain names. These information are kept also in the SQL database in the table named domains. It is able to automatically register a domain name through a service named knobin.com, and will insert the data in the table. And of course, without parameters, will display information on the web interface. The second component, the checker, is described by the checker.php script. It verifies information about the servers. So it sends specific requests to each server and expects specific answers. If a valid answer is received, some columns from the server tables are set to on. Columns as HTTP, HTTP good, DNS, DNS good. If the conditions are not met, these columns are set to off. The last component can be described by a collection of scripts handling the RC4 encryption and decryption, scripts that delete expired server from the database, different config files. Actually, here we found the template for the service XML update. The second level of proxy. Well, this is a very complex one. It is actually the level where the network anonymization is done. It is done through the tunneling technique. On each machine from the second level of proxies are open a considerable number of VPN sessions. And the traffic received from the first level of proxy, so every package received on port 80, will be forwarded through one of these tunneling VPNs. During our investigation, we have submitted a big number of abuse reports, and we could observe that with small changes, the network recovered very quickly. Its architecture is very complex and very flexible, and they can do changes that are very simple and resolve these problems. We submitted 2 types of abuse reports. The first one referred to a machine from the first level of proxy. The solution was very simple. They just repaired the network in just a few minutes. they actually switch the list of IPs between the clients. So if we have client 1 and client 2 with these list of IPs, and let's say the abuse report referred to the first IP, 111.1. After the abuse report was sent, they just switch between the lists. And of course, the first IP will not answer as before. So from the Internet service provider point of view, the problem was solved. But actually, the first client received a new set of IPs, and the network recovered and worked as before. A small change has to be done also. They have to update the service XML file on the affected clients, on the clients participating in the switch, on all the machines from the first level, so that the HTTP redirection could be corrected. The second type of abuse report was referring to a machine from the second level of proxy. Here we observed that the machine was stopped. In approximately 3 or 4 hours, a new IP appeared in the system. And in less than 24 hours, the malware was back in business. We suspected that they needed this amount of time so that they could move data from one machine to another, because actually the solution was very simple. They have to replace the old IP in the specific file of the client from the DNS server with the new one. And all it's done. It's, the malware is up and running. Also, they have to update the service XML file for all the files corresponding to the affected client on the first level of proxy. So that could, the HTTP redirection could be corrected. So, although the paper and the presentation wants to be about the entire network, I know that a lot of us wonder how CryptoLocker was a part of this network. It actually was, it is, the second client. They named it Special. And actually, the things we observed during the abuse reports were the abuse reports for the CryptoLocker malware. At the moment of the takedown on the 2nd of June, we observed that all the registered domain names for CryptoLocker did not resolve anymore to the list of IPs assigned to the second client from the first level of proxy. Their first attempt to recover from the takedown was on 10th of June. They added 2 new IPs in the system for the client 2, one for the first level of proxy, and the second one was for the second level of proxy. Of course, the attempt was unsuccessful, and just a few minutes later, they removed these IPs from the system. It was like 5 or 10 minutes. The second attempt was in August. On 5th, 6th, and 8th of August, they added new IPs for both levels, from both first level of proxy and the second level of proxy. None of them responded as valid CryptoLocker IPs, but on the path/img, there was an open directory revealing these 2 pictures, and it is actually a new approach because, as far as we know, the old interface of CryptoLocker did not contain any pictures. So they might prepare something new. We just have to wait and see. So coming back with information about the entire network, this network has a great dynamic. They make changes every day. This is a chart with the IPs added weekly during our investigation. And this is the chart with the IPs dropped weekly from November 2013 till August 2014. And as it can be seen, they were quite busy. Here is a map made on 22 September 2014. It is the map of the servers, both first-level servers and second-level servers. As it can be seen, I don't know if it shows well. There were 2 servers in Germany, 9 servers in Ukraine, 3 servers in Kazakhstan, and 8 servers in Russia. So, in conclusion, this network proved to be very resistant to abuse reports. It repaired very quickly, and in our opinion, it represents a good solution for malware creators to hide their CNC servers. And since the network resisted for such a long time, we expect in the near future to see similar mechanisms or similar solutions on the botnet market. Thank you.